So let's go. So we are doing this live. It's going to be great. We have people joining us from all over the world. And yeah, let's get started. This is the first session in the Spring Theater at SpringOne 2024. Thank you so much for being here. I'm going to hand it off. Ryan and Spencer, let's go. Good job.
Yeah, so the first thing I'm going to show you here is this disclaimer slide. I'm sure by the end of the conference, you will all have this completely memorized because you're going to see it in every single session.
Let's call it the selfie slide.
Oh, right, yeah. All right. That gave us enough time for you guys to read that. So before we get started, I'm just going to introduce ourselves. My name is Ryan Baxter. I've been on the Spring team for about 8 years now. That entire time, I've been working on Spring Cloud alongside my good friend Spencer Gibb here, who will introduce himself in a second. I work on various different Spring Cloud projects. I probably touched them all at this point, but focus a lot on Spring Cloud Config, Spring Cloud Kubernetes, and such. So Spencer, why don't you go ahead and introduce yourself?
My name is Spencer Gibb. I've been on the Spring team for 10 years. I started the Spring Cloud project with Dave Sire, and I've been working on it ever since. I lead the core team, and I spend a lot of my time in Spring Cloud Gateway recently, but my name is in all the repos at least once. All right, so let's just start. This is kind of a beginner's course. So what is Spring? It's a framework designed to take lots of different technologies and allow you to combine them in ways that feel natural. We try and provide a consistent programming model to integrate all these technologies to meet your needs. But so why do we need it?
Yes, that's a great question, Spencer. Basically, Spring just makes building Java applications easy, right? And not even just building like hello world Java applications, but real like enterprise grade, they do something meaningful type of applications. And funny story, before I worked on the Spring team, I worked at IBM, and at the time there was a ton of people very interested in Node, and they were like, oh, look at how easy it is to get up and building a web application in Node. And so I went to Google and I started Googling around, and I eventually came across this guy named Josh Long. Has anyone heard of Josh before? Yeah. He was on YouTube talking about this technology called Spring Boot. And I watched his video and I was like, I'm sold. Like, I'm sold as a Java developer, and that started my Spring journey. And really, Spring just makes Java easy for Java developers, and it's super powerful. And we're going to talk about all the different use cases that it addresses here today.
And who uses Spring? Basically, lots of people. I see Deshaun over there raising his hand. It's used across all sorts of businesses, Fortune 500s to startups to small projects. If you've never used Spring as a developer, you've likely used applications that have, whether it's your bank or healthcare provider, insurance, whatever it is, they use Spring, guarantee it. But let's take a look at what it takes to build an application, Ryan.
Yeah. So where do we get started, right? And so my good friend, Glenn, who originally gave this talk, he used this analogy of thinking about Spring like Lego bricks. And who here likes Legos? Anyone like Legos? I love Legos. Like, I built Legos as a kid, and now I build them as an adult with my son. But it really is a great analogy to thinking about Spring. So when you start with a Lego, you start with this like base block that you then construct and put everything on top of, and eventually you end up with this amazing creation at the end of the day. And that's very similar to how Spring works. And at the core of Spring, at the base of Spring, is Spring Framework. Now, Spring Framework has been around for 20 years. It celebrated its 20th anniversary last year, so it's about 21 years old at this point. And it provides all the things that you'd expect out of a great framework. So dependency injection, eventing, validation, testing tools, support for getting data from databases, observations, all kinds of stuff. But we're not some old legacy framework. We are continuously integrating the latest and greatest technologies into the framework to keep it up to date with the industry as it moves forward. So, Spencer, how do we kind of get started, building an application or something that can help us, get going, and where do we go from there?
So, a number of years ago, the Spring Framework team came up with this new project called Spring Boot. Maybe you've heard of it. They created it as the simple way to get into the Spring framework. This is the entry point. It provides aggregations of all these different technologies and allows us to get started solving problems very, very quickly. So it's built for the speed of the developer, and they provide conventions, they provide defaults, but if you need to go against the opinion of Spring Boot, they make it fairly easy to use your own opinion depending on what your company needs. And we'll see some examples as we go along today. So now that we know what to use, how do we go about doing that?
Right. So Spring provides a whole bunch of different projects that you can use to satisfy your business use cases. Whatever you're trying to build, there's a project for it. So if you need security, we have security. If you need to get data from a database, you got Spring Data. If you need to build microservices applications that are going to run in the cloud, you have a Spring Cloud, right? And so as you start to add these bricks on top of each other, in the beginning it's fairly simple, but as you start to layer things up, it becomes quite complicated, overwhelming. Each project has its own dependencies. Each project has its own dependency versions that you need to worry about. And so it becomes overwhelming from just trying to keep track of everything. And so, Spencer, is there something else that we can do here to make things a little bit even easier than that?
Yeah, let's just start with the basics, right? We'll go through some of these projects and show a little bit about each one. But let's start simple, right? We need a couple of applications to talk to each other. Let's start there.
Yeah. So that's a really good place to start. It's like kind of your basic situation. I have two apps. They need to communicate in some way. So the most obvious solution to that might be using something like REST, right? And so Spring has a solution for you there, and it's called Spring MVC, or Model View Controller. I'm sure everyone's familiar with that pattern. And the cool part is that Spring MVC is actually built into Spring Framework. So it's right there at the base layer. But you need more than just Spring MVC, right? You need some kind of web server to host the application, for example, right? And that's where things like Spring Starters come in. And so Spring Boot provides Spring Starter Web, and it pulls in everything you need to build a web-based application.
But what about data? I need to store this information. It's just not ephemeral, right?
Yeah. So that's a great point, right? So an application is actually going to need to probably retrieve or persist some data at some point, and that's where Spring Data comes in. So Spring Data to the rescue there. And again, Spring Data provides just this base level consistent API for accessing data across various different data stores. So we support a whole bunch of different ones, and the API is fairly consistent across all of them just by using Spring Data. And again, Spring Boot saves the day here by providing starters for each one of them. That makes integrating with whatever data store you want fairly easy.
I have a hard time understanding a little bit of consistent API against multiple databases.
Yeah, it's true. It's not fictional by any means. So no matter whether you're trying to use a graph database, a relational database, a document-based database, key value databases, etc., we have a starter and a project in Spring Data that allows you to use whatever technology or database you really want to use. So pick and choose what you want. All you're going to do is just swap in the starters that you need or swap out the starters that you need, and you can get going.
Awesome. All right. So I don't want my application to show up in the news. Sorry about the feedback.
Maybe we shouldn't stand so close to
Yeah. Right? I want to be in the news for good things, not for breaches in security. How can Spring Boot help us?
Yeah, so security is definitely an important topic, and luckily Spring Security saves the day here. We have some incredibly smart people that work on the Spring Security team, one of which is standing in the back over there.
Right there.
And we'll be giving talk on Spring Security specifically a little bit later on in the week. But Spring Security can do just like basic authentication. So if you just need username and password, you want to secure your app that way, we got your back there. It protects against basic common attacks that you might experience. So session fixation, clickjacking, cross-site forgery requests, that type of stuff. Just out of the box, kind of secures your application. If you want to take it a step further and you want to do something like authorization, we got you there too. So Spring Security supports OAuth 2.1 and OpenID Connect. We even provide the Spring authorization server to help you along your way as well.
All right, so how do we start? Let's go to Josh's second favorite place on the internet, start.spring.io, the Spring Initializer. This takes a boot-centric view of the world, so this is all configuring a Spring Boot application for you. And it's the entry point for the entire Spring portfolio. So let's get going. So when we add a dependency on the right side there, this pulls in what we call a starter. And a starter is it's a POM file. It's a collection of technologies that are required for any particular problem. You'll see on the right there, there's no version numbers, right? The only version that we've selected on the left is the Spring Boot version. And so Spring Boot manages the versions of all these things so that we get consistent working integrations among all these technologies. So let's dive in and see how these versions work together. So we'll take a look at the security starter here. So we start with the boot version, and all these other technologies can have their own individual versions. You don't need to know what version of Spring Framework that Spring Boot requires. You don't need to know the version of Spring Security. They each have their own versions listed there. But what about upgrading? Say we want to upgrade Spring Security, right? You just upgrade the version of boot, and you get all the upgrades for free. It's really, really, really nice.
I think Netflix talked about that.
Yeah.
You know, right?
Yep. And so here we can see the part of the web starter. We can see Tomcat. We can see Jakarta. Again, boot manages these versions for you, but if you really want, you're using this Spring Boot as the parent of your project, you can specify a version. Say Tomcat came out with a fix that you need immediately and can't wait for boot to upgrade. You can set a property that will change the version of Tomcat, for example. It's time for a demo, I think.
Demo time. Definitely my favorite time. Okay, so I'm going to try and switch things up here so you can see the screen here. Let's
It worked.
Let's go over to okay, let's try that. Okay. So we're going to go to start.spring.io, right? This is where we want to be. This is where you're going to get started. So we're going to select just a couple of defaults out of the box here. So we're just going to use Maven. We'll use Java. We're going to use the latest and greatest Spring Boot 3.3.3, which was just released last week, I believe. We're going to give our artifact a name here. So we'll call it what is Spring. And we're going to choose Java 21 here. And we're going to add a couple of dependencies. So we'll start off building our web application. So we're going to use Spring Boot Starter Web. And then, because Spring is super up to date with the latest and greatest and coolest stuff, we're also going to add a little AI in the mix, right? Because who doesn't like a little AI today? And then we're also going to talk a little bit about some of the performance benefits that you can get by using Spring. So we're going to also add this GraalVM native support to our application. So we have a couple of dependencies here, and we're going to go ahead and generate the project. So we'll go ahead and get this zip. We're going to open it up, and we'll open it up in our IDE here. All right, so let's just take a quick look at what start.spring.io gave us, right? So we have our POM file here, and can everyone see what that on the screen? Okay, cool. So we get our starter here. We have our Spring Boot version that we get, right? So if we want to upgrade Spring Boot, when the next release comes out, we're just going to change this version here. We get some metadata about our project, nothing really cool there. We have our Java version here. We have our Spring AI version, which we'll come back to in a second. I'll explain what that property is for. We see our starter here. So this is that Spring Boot Starter Web that we talked about in the slides. This is a starter for OpenAI from Spring AI as well. We get this testing starter, which helps us out writing some unit tests, which is super cool. And then we have this dependency management section down here where you'll see that we use that Spring AI version. And that's because Spring AI contains a number of different projects inside of it. So it contains its own bill of materials to manage those versions and et cetera, right? So we're importing that bill of materials so that we can then pick and choose the Spring AI projects that we want out of that mix. This is a common pattern in Spring that you'll see when a project like Spring AI or, for example, Spring Cloud has multiple sub-projects that it has its own bill of materials that manages versions for that specific release. Scrolling down a little bit further, we have our build plugins. So we have our Spring Boot Maven plugin, which is responsible for creating a jar file, an executable jar file for us. And then we have our native Maven plugin, which is going to be responsible for creating a native binary for our application. Other things that came down in the zip file here, we have our main application class. Again, nothing really terribly interesting here. We just have a public static void main here, so nothing really mind-blowing. And then we get an application properties file, and this is where we can place any kind of configuration that we might want to configure from those opinionated defaults that Spring has. So let's get started here building our application. The first thing we're going to do is create a configuration class. And I'm also not good at naming things just like Josh, so I'm going to call it my config. And we're going to create a bean here. And we're going to use this bean a little bit later on, but it's going to be a type of called chat client. So chat client is a way of integrating with ChatGPT from Spring AI. So we'll call this chat client. And it's going to take in a chat client.builder. And this builder is already initialized for us. It's part of the auto configuration that's coming from that starter from Spring AI. So it allows us to customize the chat client however we want. Luckily, we don't really need to do any customization. We're just going to return the defaults as is. Now we can go up here and we can actually create our endpoints, our REST endpoints for the communication for our app. So here I'm just going to create what's called a REST controller. And again, my awesome naming conventions, we'll call it my controller. And my controller is going to take in a chat client, but it's also going to take in one other thing here. And that's an OpenAI image model. Because in addition to using ChatGPT, we're actually going to generate an image. And that's a class that's going to help us do that as well. And so we'll create a private final OpenAI image model. And then here we will say this dot OpenAI image model equals OpenAI image model, and we'll get rid of this pop-up here. Cool. All right, so we have the classes that we need to actually do something here. So we're going to create a get mapping here, and we're going to put it at the root of the application. And we're going to public string index. And in here, we're going to say return chat client dot prompt dot, oops, I can type, dot user. So here we're going to enter our prompts of what we want to say to ChatGPT, right? We're going to say, tell me about the history of Spring Framework and Spring Boot. All right, and then we're going to we'll call that, and we're going to get the content, the response from ChatGPT. We'll add one additional endpoint in here, so we'll create another get mapping, and this will be at /image.
Get is the HTTP, right?
Right. So that corresponds to an HTTP GET request to our application. So here we're going to turn a redirect view. This is coming from Spring MVC. And this is because we're going to redirect to a URL of an image. Image, okay. I didn't want you to do that. So call new image prompt. And so we're going to prompt it for what image we want it to create. So we'll say create an image that represents Spring Boot and Spring Framework. And then we're going to say .get results, .get output, .get URL, and we're going to redirect to that URL. Cool. So we have our application written here. And so let's go ahead and we'll compile this code, get a jar that we can actually run and test it out. So make this a little bit bigger here. So we'll say /mbmw clean package -d skip tests and
YOLO, right?
yeah, YOLO, and it just runs faster. And every second counts when you only have 45 minutes. All right, so then we're gonna say java-jar, oops. And then, so it starts up here, so we can go back to the browser, and we'll say localhost 8080, and we'll wait for ChatGPT to give us a response, so it should tell us about the history of Spring and Spring Framework, so we get that text back, which looks pretty accurate to me. You know, it always hallucinates sometimes, but that seems pretty good to me. We can also go in here and say, and take a look at what it thinks an image represents Spring Boot and Spring Framework. This typically is a little bit more interesting. It gets very confused about springtime and trees and flowers, and then it throws in maybe a occasional boot in the picture. But actually, that's pretty good. That's pretty good. Usually, you see some kind of boot that shows up with flowers and all that stuff, but that's actually pretty good. So it's doing fairly well today. Cool. So just a couple things I want to point out here about the application that's running. So it took about a little over a second and a half. So 1.7 seconds to start up. We can check out the memory usage of that jar as well. So we're going to say, let's find the process ID here. And then we're going to say PS. And then we're going to get specifically the memory usage. And so it's taking around 240 megs to run that jar. Okay, so keep that in mind. We're going to come back to this in a second, but what we're going to do next is actually compile this down to a native binary, and then later back on in the presentation, we'll come back and check out how much faster it can start up and how little memory it can actually use. And so we're going to take advantage of that Growl native plugin that we had in the POM file. So we'll say mvmw, clean package in that profile. That pnative profile comes as part of that plugin, and then we're going to execute the compile goal that comes along with that. Now it's going to take a couple, about a minute or so to run. So while that's doing its thing, we're going to jump back in the slides and talk about some other use cases.
Before we jump back in, I noticed it ran on port 8080, but you didn't tell it to do that. What?
Yeah, so that's one of the opinionated defaults, right? One of many opinionated defaults that Spring has, right? We usually just start application servers and they start on port 8080. But if for whatever reason you don't want to do that, you come into your application properties and you can set this server.port property that you see here with the nice type ahead here that we get in the IDE. And you can change that default to be 9090. It could be some random port. It could be whatever you want, right? And that's true for any of the opinions that you might have as part of Spring. All right, so we're gonna switch this back here. And
Sweet.
back there.
Through a few more. All right. So we've got an application now. It's got some endpoints. Now we're starting to grow. We get more and more endpoints. A lot of times it's difficult to have all these different clients out there that have different needs, maybe just a subset of the data, or they want their own little custom bits of it. What can Spring help us to do so we're a little more efficient in that regard?
Yeah, so certainly, there's a technology out there called GraphQL, which allows you to basically be very selective about the data that you get returned, the amount of data that get returned, the number of APIs that you hit. And is super powerful in cases where you're very concerned about bandwidth utilization. So if you have a mobile app, for example, and you have tens of and maybe more 20 different microservices, you're trying to request data from a lot of these microservices. It allows you to be very selective about which microservice you're going to get, which data you're going to get back, the size of that data, etc. right? So luckily, Spring has integrated with GraphQL, and we have Spring for GraphQL, which allows you to be super efficient about the data that you're getting back in those types of scenarios.
Yeah, they worked with the GraphQL team. They also worked with the Netflix team on their use of GraphQL. So, but were we just swapping it out? I mean,
well, it's
the deal there?
yeah, it's up to you. I mean, you can choose both REST or in GraphQL or one or the other. But again, like it's we have some opinions, and you can customize it however you feel fit for your best the use cases that work best for you.
Spring Framework for the win. All right, so we've got the application. It's in production. I know you write bug-free code, but the rest of us mortals tend to have bugs. What happens? When we get the call at 3 a.m. What can Spring do to help us there?
Yeah, I wish I wrote bug-free code, but it's just not the case.
Never.
In my dreams. So that's where something like there's two different things that Spring's going to provide here that can really help us out when we get that dreaded call. So we have Spring Boot actuators, and if you were watching the keynote, there was a great demo of visualizing these actuators on the Tanzu platform that was shown. And so basically, these actuator endpoints, they provide just like information about the current state of your application. So you can see things like what's the current configuration values that are set, system properties, that type of stuff. You can see like memory utilization, the Java heap, that type of thing. And because this is integrated throughout Spring, every time you add a new Spring project into the mix, if they have actuators, they get contributed into that mix as well. So, for example, when you add Spring Data, you're going to get the Spring Data actuators. When you add Spring Security, you get Spring Security actuators, etc. The other tool that we have for you is integration with Micrometer. And Micrometer is actually integrated all the way down in that base level there and the Spring Framework level. And it provides just monitoring, tracing. It shows you what's going on in your application. And it integrates and allows you to visualize all that stuff in your favorite, visualization tools, Prometheus, Datadog, Influx, that type of stuff. And again, because it's at the base layer, everything that comes on top of that, which is everything else in the Spring portfolio, gets Micrometer as well. So you get tracing and observability throughout the whole stack.
One of the maintainers is sitting right over there. Raise your hand.
Jonathan.
He's going to talk about it later this week, so look forward to that. All right, so now we can see when there are problems, but say I need to change something quickly, right? Maybe I'm reacting to that 3 a.m. call, or I need to change a feature flag, or something like that. What do we have that can help? Maybe this hits close to our home, huh?
Yeah, this is where I spend a bit of my time as well. So here we have in the Spring ecosystem something called Spring Cloud Config. And so Spring Cloud Config is all about implementing this best practice of externalizing your configuration from your application. That way you can adjust this configuration without having to rebuild your application when you need to do that, right? So there's two pieces to Spring Cloud Config. There's a config server and a config client. The config client integrates with your application, says it makes a request to the config server and says, give me all the configuration for my application. The config server obviously responds back with that configuration, and then the application will start up. Now, behind the config server is what we call an environment repository. This environment repository is what persists and stores all the configuration. So we have support for a number of different types of environment repositories. Maybe you want to store your configuration in Git. Maybe you want to store it in HashiCorp Vault. Maybe you want to store it in a JDBC database. There's plenty of different options for you to choose from as far as where to persist your configuration. So you just go into that data store, whatever you choose, you flip whatever configuration you need, and then the config server, or there's various different other ways you can go about doing this, but eventually something needs to tell the client that the configuration needs to be refreshed. So once the client receives that refresh request, it will go ahead and update all its configuration in place while having to restart the application. So when we need to enable extra debugging because we got that 3 a.m. wake-up call, we're not really sure exactly what's going on, we're going to make that configuration change and then go ahead and refresh the application. And all of a sudden, our extra logging is now appearing, and we'll probably track that via Micrometer and stuff like that. So Yeah, that's a quick solution to that problem.
Awesome. So we've got that out of the way. So far we've been talking about REST, HTTP, right? There are some folks that say microservices are better done with messaging, right? We want to talk asynchronously. What can Spring help with that?
Yeah, do you have a specific messaging framework in mind?
All the messaging frameworks.
All the messaging frameworks.
How about Rabbit and Kafka?
Yeah, so we have Spring for Rabbit, which will support Rabbit. We also have Spring for Kafka, which we can support that. And we even have Spring for Apache Pulsar as well. So no matter what messaging framework you choose, we have a Spring project that can support you there. And then kind of sitting in front of all that is Spring Cloud Stream. And this, just kind of like Spring Data, provides a consistent API for you to integrate with the messaging framework. So you can choose whatever messaging framework you want. You get this nice consistent API. If in a different application you want to use Rabbit or Kafka or Pulsar, you go ahead and you use that dependency, but the way you interact with the messaging framework remains pretty much exactly the same because Spring Cloud Stream is doing all the hard work for you.
I was super excited when I first saw the first demo years ago of it for message-driven microservices. I was really excited about it.
Yes.
All right, so growing again, more APIs. We need a consistent way to handle common things among all these APIs, like cross-cutting concerns, security, maybe some tracing, things like that. Might there be anything that I know about that we do here?
You mean something that you actually wrote? Yeah, so that's Spring Cloud Gateway, and Spencer's going to be giving a talk later on this week about Spring Cloud Gateway specifically. And that provides an entry point for all your API requests, right? So if you have a lot of applications, you have a lot of APIs that people are going to be using, you throw Spring Cloud Gateway into the mix, and it provides a central entry point for all your APIs. And that's where you can start implementing your cross-cutting concerns. So if you need to implement security at the gateway, you can provide circuit breakers at the gateway to do resiliency. All your tracing can be taken care of at the gateway. So it is that entry point into your API ecosystem to allow you to implement all those cross-cutting concerns.
It's a decent project.
It's
all right.
It's all right.
Yeah. All right.
There's a couple bugs in there.
Yeah. Oh, I know about it. So far, we've kind of talked about these long-running applications, right? That are supposed to be available all the time. But that's not everything an enterprise does, right? We have things that have to be scheduled, at 2 a.m. to do something, or we have a one-off job that we need to do. How can Spring help me with those kinds of workloads?
Yes, that's where something like Spring Batch will come in. So Spring Batch is a lightweight, comprehensive batch framework designed to enable development of robust batch applications, vital for the daily operations of your enterprise. So if you need to, run tasks that happen to occur every so often, process a whole bunch of records, that type of stuff, clean up a bunch of stuff, you can write a batch job that would actually do that. And if you need to do it in a 12-factor manner, you can use something like Spring Cloud Task, which allows you to build a microservices-based batch operation. And if you want to start to stream together and orchestrate a whole bunch of these batch jobs together so they run concurrently or synchronously after each other, that's where you're going to use something like Spring Cloud Data Flow, so you can design, this batch job, that batch job, that batch job after that. And so, the solution for that as well.
Great. Love it. So now I want to pad my resume. I want to do serverless. There are legit reasons to do serverless. Cost savings, flexibility. What can we do with that?
Yeah, so luckily we have Spring Cloud Function, and our good friend Oleg is going to be giving a talk about this a little bit later on too, so look in your schedule for that if you're specifically interested in serverless. But much like Spring Cloud Data, is providing this abstraction layer over the different cloud providers' serverless offerings, right? So whether you're using Azure or GCP or AWS, it doesn't really matter. Spring Cloud Function provides an abstraction layer for you to run these serverless kind of quick running operations.
There's basically a starter for each one of those.
Each one of those, right? So this is a pattern that you're seeing over and over again here. In addition, when you're running these serverless functions, the time that it takes to start that application up from nothing to running to handle the function that you want to run is important, right? So there's two solutions here that we're going to talk about. First is Project Crack. Project Crack stands for Coordinated Restore at Checkpoint. It's an open JDK feature that's part of the JDK, and basically it allows you to create an image of your application so that you can start it up much quicker. So it's starting from this image that you created in the startup state. And we have support for this built into Spring Framework 6.1. So that means you can take advantage of it today and in your serverless applications. The other thing is something we already kind of touched on, is that's native app compilation. So let's take a look at how much more performant an app can be when we compile down to a native binary. So we're gonna switch back here. We take a look mirror. Go back to our IDE. All right, everyone can see that. So we got our native binary that finished compiling here for our application. So let's go ahead and start that up. There we go. So you can see how fast that started up. It took approximately 20 milliseconds. And so for those of you who don't remember how long it took before with the jar, I'm one of those. It took 1.3 seconds to start up, right? So much quicker to start the native binary than the jar. We can also, again, take a look at the memory utilization here of the native binary. So we get the process ID for that, and then we'll see how much memory it's taken up. And we get 70 megs. So before, with the jar, it was 240 megs, right? So that's a huge cost savings as far as resource utilization when you compile down to a native binary. Cool, so we got that. So let's go ahead and jump back into the slides again. There we go.
All right, so we've talked a little bit about efficiency on the Spring Native side with Checkpoint Restore, but there are certain applications that have a different, consumption model of resources, and we need to get better performance out of those than just the standard, kind of old style servlet blocking way. What can Spring do for us here?
Yeah, so we have a couple of options here for you again. So first one is Project Reactor. In Project Reactor, it implements the reactive stream specification and provides non-blocking I/O for your application. So you're going to write asynchronous code when you use Project Reactor. It's actually what the Spring Cloud Gateway was originally written in, was using Project Reactor, because when you think about it, a gateway is a high throughput application. It needs to handle a lot of incoming traffic potentially. And so having a non-blocking application server or application is very beneficial in that use case.
And that would be what the framework uses as part of Webflux, right?
Yes, correct. Yep. So nice. Webflux would be the equivalent there. And then the second solution here is if you want to stick with writing synchronous code, which is much easier to reason about. It's what most of us are traditionally think about when we write Java applications. We have support for what's called Project Loom. That's part of Java 21. And again, this is already supported in Spring Framework 6.1, so you can take advantage of it as long as you're using Java 21. And Project Loom reduces the effort for writing, maintaining, and observing high throughput concurrent applications. And the primary way it does that is by using virtual threads. So instead of relying on actual threads from the hardware, it creates a bunch of virtual threads, which actually end up being dependent on the load on the application, can be more performant than the threads from the CPU as well.
All right. So we've talked about mostly runtime components up until now, right? But how about architectural design? Is there any way to get consistency across our portfolio of projects in our organization?
Yeah, so for anyone who ever worked on an application for a long period of time, it starts very simple and then starts to grow and can become just out of control, right? For lack of a better word. So we have a newer project called Spring Modulith. And if you were watching the keynote, you probably heard about Cora talk about this. But Spring Modulith provides an opinionated toolkit to build domain-driven modular applications in Spring Boot. So it enforces you to adhere to well-designed application structures. It does that using something like unit tests. And so you basically create tests to make sure the structure of your application doesn't grow to like some kind of crazy out of control fashion and becomes unwieldy. So the test will fail if someone kind of breaks your rules, and then they have to go back and fix it to adhere to the design principles that you're trying to enforce.
Yeah, Cora gave a great demo of that earlier today, and I believe she'll be talking about it later this week as well.
Yeah.
Awesome. So now where do we run these things? I just spotted the Spring Cloud stream and function maintainer at the back of the room. If you want to raise your hand, Oleg, say hi. So where do we run Spring? Obviously, you've seen us run it java-jar, right? Run the native image just here on the laptop. So you can literally run Spring anywhere. But one of the great places that Purnima talked about in the opening keynote was the VMware Tanzu platform, both for Cloud Foundry and for Kubernetes. They have a whole suite of data services, databases, whatever you need, whether that's something like Redis or a JDBC database, relational database. They have the application catalog for other applications that you need for your application. You also get support for Tanzu Spring, right? So support for all your applications that are written in Spring. You also get managed versions of the config server that we talked about, managed versions of the Spring Cloud Gateway that integrates with security and does MTLS and all sorts of other very nice things that happen at that level. So here's our little commercial deal for our Tanzu platform.
Cool. So why Spring, right? So we covered a whole bunch of use cases today to really illustrate why you might want to choose to use Spring. You can pick and choose the technologies that you want. It's been around for a long time, and as you saw, yes, we've been around for 20 years, but we are integrating the latest and greatest technologies from OpenAI to what's coming out in the JDK constantly, right? So we're always keeping up with the latest and greatest technologies. We have official Spring support, so if you want like someone to help you out, you get stuck, you have bugs, you have issues, you need more support, we get that. We have that for you as well. And because Spring is so well adopted, it's very easy to hire developers that work on Spring. It is one of the most popular frameworks. We continue to grow. We've seen 50% growth of Spring Boot over the past 5 years. So it's just a great technology to use, and it does make your life very simple as a developer. So with that, I encourage everyone to take the survey. We appreciate any and all feedback. If you have questions, we have about 3 minutes or so to take questions here.
And we can obviously take more after.
Yeah, after. And if you have questions you want to ping us on X or Twitter, please go ahead, and our Twitter handles up on the screen too. Does anyone have any questions in the audience? Yep.
Is there any possibility whenever I update the configs, let's say I have 1,000 applications in my yard, and I updated one config file,
Yep.
How would I ensure that all the 1,000 applications I should not restart or restage or something else?
Yeah. Okay. So the question was, maybe Spencer can help me out here. The question was, if you have like 1,000 applications, you update the configuration, 1,000 instances of that application, you update the configuration for those 1,000 instances. You want to make sure that the application, all 1,000, doesn't restart at the same time, right?
Actually, you probably want them to roll at restart. You don't want all of them all at once, otherwise you'd be down. But there's a project called Spring Cloud Bus that allows you to. It's basically kind of like a distributed actuator. Uses a messaging service to ping each application and say, "Hey, reload."
Yeah. So we don't like specify how you should do the restart. We provide tools for you to do that. So you could use Spring Cloud Bus and send a message to all 1,000 applications. There's also an HTTP endpoint that you can use to do that. You can design your own way of making sure you have a rolling restart. So for example, if those 1,000 instances were running on Kubernetes, for example, you could use Kubernetes to do like a rolling restart of those applications, trigger something in Kubernetes that would do that. Yeah.
Awesome. Well, thank you for setting our first presentation at the Spring Theater, this VMware Explorer. So thank you very much. We appreciate your time.